Hello and welcome to my channel. Walter here, and today we are going to be looking at paper 11 from the October-November 2023 sitting. So we are going to get started with this paper, but before we do, I would want you to check in the description of this video for a free resource that I have designed for you, which is a revision ebook, which you can make use of as you prepare for your exams. So you can find that in the description. So now let's get into the paper. All right. So starting with question number 1, it says, expand 1 plus 3x raised to the power of 6 in ascending powers of x up to and including the term in x squared. Okay, so here, this is binomial expansion, and we are going to make use of the list of formulas, and particularly, we will make use of this formula, which we find in our list of formulas, all right? So this is what we're going to use for the binomial expansion right here, okay? So since we have 1 plus 3x raised to the power of 6, this is going to be 1 plus 6 of 3x plus 6 of 5 over 2 factorial, and that's of 3x squared, all right? So they say it's up to the term in x squared, so we will end here. We know it goes to up to the term in x power 6, but they just want us to end at the term in x squared, all right? So we can simplify this. This is 1 plus 18x plus, and here, if we say 6 times 5, that's 30, divided by 2 factorial, that's 15, and 15 times 3 squared is like 15 times 9, and that gives us 135, and that's x squared, all right? It goes on and on, but they want us to end at the term in x squared. So this here happens to be the final solution, all right? So that's how we do it for part A. Let's go on to the next part, which is part B. So scroll in. Now on part B, the question says, hence find the coefficient of x squared in the expansion of 1 minus 7x plus x squared of 1 plus 3x raised to the power 6. All right. So here we have 1 minus 7x plus x squared, and it's multiplying 1 plus 3x raised to the power 6. Now, we have already done the expansion of 1 plus 3x to the power 6 up to the term in x squared. So we are going to make use of this, and this will help us find the coefficient of x squared, right? So I'm going to paste it here, and we will have it like this, all right? So to get a term in x squared, I'll write that down. For the term in x squared, we are going to have 1 multiply one of the terms in the second bracket to give us a term in x squared. So that will be 1 multiplying 135 x squared. So that will give us a term in x squared. And we will have minus 7x multiply 18x to give us a term in x squared. And we'll have also x squared, this x squared, multiply 1 in the second bracket to give us a term in x squared. So we have right here 135 x squared, and it's minus 7x times 18. So 7 times 18 minus 7 times 18 should give us minus 126 of x squared, and it's plus x squared. All right, so we will do 135. Okay, let me just use the calculator. So 135 minus 126, and it's plus 1. This gives us 10. So the term in x squared is 10x squared. Now the question says we should find the coefficient of x squared, which happens to be 10. So the coefficient of x squared is coming out to be 10. So this here is the answer. That's what we get right here on part B. Let's move on to the next question, which happens to be question number 2. It says a line has equation y is equal to 2cx plus 3, and a curve has equation y is equal to cx squared plus 3x minus c, where c is a constant. Showing all necessary working, determine which of the following statements is correct. So we have these 3 statements here, which we are going to look at after we do the work. And actually, statement A says the line and the curve intersect only for a particular set of values of C. B says the line and the curve intersect for all values of C. And C says the line and the curve do not intersect for any values of C, right? So we have 3 options here, right? So it looks like we are looking at the intersection of 2 curves, all right? We have a line in the curve in actual fact, all right? So we are going to solve the 2 equations simultaneously. So I'm going to equate the equation of the curve. So I'll take the right-hand side, the cx squared. So I'm writing it down now. So I want to change color here. Cx squared plus 3x minus c, and it's equal to 2cx plus 3. All right, I'll take what's on the right to the left. So we'll be having cx squared plus 3x minus 2cx minus c minus 3 equal to 0. Okay, so this is cx squared plus, and I'll factor out the x. So we'll be having 3 minus 2c. Okay, that's a c of x, and it's minus of c plus 3. All right, and it's all equal to 0. Okay, like this. Okay, so we are going to do the discriminant so that we can have an understanding of the interaction, how the line and the curve are related. Do they intersect? How many times do they touch? And all that. And that will help us to answer the question, all right? So the our A is C. B is 3 minus 2C. And C is minus of C plus 3. All right, so this is what we have for A, B, and C. So we're going to do the discriminant. So B squared minus 4AC is 3 minus 2C squared minus 4 of C of minus of C plus 3. So the minus on C plus 3 will be transferred here so that this becomes a plus, all right? Let me write that down. So that's a plus. So we'll just be having C plus 3 here. All right, let's simplify. So that's 9 minus 12C plus 4C squared. And this plus, simplifying here, that's 4C squared plus 12C. All right, so let's simplify this a little bit more. So starting with the C squared terms, 4C squared plus 4C squared gives us 8C squared, and minus 12C plus 12C gives us 0. So we are just left with a 9, so it's plus 9. Now, if you look at what we've gotten for the discriminant, we have gotten 8C squared plus 9. And if you look at 8C squared plus 9, for any value of C, we know that, let me just write that down. For any value of C, this 8C squared plus 9 will always be positive. And we know that if the discriminant is positive, that is when the discriminant is greater than 0, it means that we have two distinct roots, and it actually means that the line and the curve intersect, all right? They intersect at two distinct points. So if you look at the options we have, the first option, A, says the line and curve intersect only for a particular set of values of C, all right? Which is not really true, okay? Because we've discovered that they intercept for any value of C, all right? On B says the line and the curve intersect for all values of C. So actually it is statement B, which is correct. So I'll say here, because of this, therefore, statement B is the correct one, right? So therefore, B is the correct statement. Okay, so that's the answer right here. That's the answer to this particular question. All right. Let's move on to the next question. On number 3, it says, the diagram shows a cubical closed container made of a thin elastic material, which is filled with water and frozen. During the freezing process, the length x centimeters of each edge of the container increases at the constant rate of 0.01 centimeters per minute. The volume of the container at time t minutes is V cubic centimeters. Find the rate of increase of V when x is 20. Okay. All right. So how do we answer this particular question? Is the big question. So here, from the information we have been told that the edge here, the edge of the container increases at the constant rate of 0.01 centimeters per minute. So we can write that as dx by dt is equal to 0.01. Now, we also need to consider the volume of the box, and since it's a cube, we know that we can find that by V is equal to x cubed, right? Which means we can find dV by dx to be 3x squared, all right? So with what we have, we now have dx by dt. We now have an expression for dV by dx. And the question says we should find the rate of increase of V, which is dV by dt. So we can apply the chain rule and say that this is the same as dV by dx times dx by dt. All right, so that's the chain rule here. And if you look at the dx's, they would kind of cancel. So this actually is a correct chain rule for us to use. All right, so dv by dx is 3x squared, and we're multiplying that by dx by dt, which is 0.01. Okay, so we are going to be having 0.03 x squared right here. But the question says we should find the rate of increase when x is 20. All right, so I'll say here, since they're saying that x is equal to 20, it therefore means that the dv by dx, by dt, will be equal to 0.03, okay, so 3 of 20 squared. Okay, let me just do the calculation here. 0.03 times 20 squared, and I'm getting 12, okay? So we should get 12 for dV by dt, and the units should be cubic centimeters per minute. All right. So that's the answer right here to question 3, and that's how we do it right here. Let's move on to the next question, all right? Okay, so we are going on to question 4. Right, so on question 4, they say the transformation R denotes a reflection in the x-axis and the transformation T denotes a translation of 3 and minus 1. So on part A, find the equation y is equal to g of x of the curve with the equation y is equal to x squared after it has been transformed by the sequence of transformations R followed by T. All right. So g of x means R followed by T is the final equation of the curve with the transformation in the sequence R followed by T. All right, so let's answer this. I'll say here, let f of x be equal to x squared. So we are transforming this, all right? Now, if we apply, so I'll say applying the transformation R first. R is a reflection in the x-axis. So we'll be having the function being minus of f of x. All right. Which happens to be minus x squared. Then applying the transformation T. T is a translation of 3, which means 3 units in the positive x, and minus 1, which means minus 1 unit in the y-axis. So in function notation, we still have the minus f, and inside the bracket, we'll be having the x, and to transform by 3 units in the positive, we put minus 3 inside, and minus 1 in the negative y in the y, minus 1 in the y is minus 1. Okay, so this is what we have. And how do we express that in how do we express it? It will be minus of x minus 3 squared minus 1. So therefore, we are saying that the g of x is that minus of x minus 3 squared minus 1. So that's the answer right here. So I use the method of function notation, all right? Applying the transformation to the function notation and then translating that to the form of the equation that we will then be having after the transformation, okay? Let's go on to part B. So this is the answer right here to A. Let's move on to B. On part B, the question says we should find, okay, let me scroll down a little, find the equation y is equal to h of x of the equation of the curve with the equation y is equal to x squared after it has been transformed by the sequence of transformations t followed by r, all right? T followed by r. So this is now t followed by r. So we start with t. So I'll say here, applying the transformation T. Okay, let's start with applying the transformation T. Remember, I had said let f of x be x squared. So we're still working with that. All right. So the transformations T are the translations, right? T is the translation of 3 and minus 1. All right. So let's apply that to the function. All right. So that will be, if it's 3 and minus 1, it will be f of x minus 3, and that's minus 1, all right? Which, well, happens to be f of x minus 3 on x squared is like x minus 3 squared, and a -1 outside, so -1. Next up, applying the transformation R. If we apply the transformation R, what is R? Remember, R is a reflection in the x-axis. So we're just multiplying the function by -1. Okay, so it'll be minus of whatever we have. It's minus of f of x minus 3 minus 1. Sorry, let me use the right bracket. All right, so this is going to be minus of this whole thing of x minus 3 squared minus 1, which therefore will give us h of x as they require. It will be minus of x minus 3 squared plus 1. So that's h of x right here. Okay, so that's how you do it with these questions right here. Now there's a part C which says state fully the transformation that maps g of x onto h of x. All right, so g of x onto h of x. Let's compare the two. All right, we have g of x being minus of x minus 3 squared minus 1, and h of x being minus of x minus 3 squared plus 1. So the difference, okay, the curves are the same except for the fact that there's a difference in the translations. Okay, this part, the -1 here and the +1, that's where the difference is. But all the other parts are correct, which means it's a difference in translation. All right. So how do we move from g of x to h of x? How do we move from -1 to 1? It is only when we add 2 to g of x. If we say -1 plus 2, that will give us +1, okay, which is the +1 we have on h of x. So technically, we are saying that the transformation is simply a vertical translation, okay? And it's a vertical translation. Let me scroll down a little. Okay, let me just write that down. So I'll say here, it's a translation. It's a type of translation in the y-axis by 2 units, so 0, 2. Okay, that's just basically how it is. And the reason is because the curve h of x, we find it by simply saying the function g of x plus 2. Okay, so the plus 2 is a vertical translation. And I think I had explained how that is. From -1 to 1, we're just adding 2 to -1 to get +1, and the 2 are the same. So it's a vertical translation. I think I've overemphasized that, so it's okay. Let's go on to number 5. On number 5, the question says, on part A, show that the equation given may be expressed in the form a cos squared x plus b cos x plus c equal to 0, where a, b, and c are integers to be found. All right, so here, let's have the equations as they are, right? Or okay, I'll just be simplifying them. So we have 4 sine x, and for 1 over tan x, we know that tan x is sine over cos, right? So if it's 1 over tan x, it's as good as cos over sine. So that's what we have on 5 over tan x. So I'll just write that as plus 5 cos x over sine x. All right. So that's how we're going to do it right there. Okay, and it's plus. Here we have 2 over sine x. I'll just write it as it is, and it's equal to 0. Now from here, I'm going to multiply all the terms by sine x to get rid of the fractions. So this term by sine x by sine x by sine x, and 0 times sine x. So when we do that, we'll be having here 4 sine squared x plus, here the signs will cancel, so it's 5 cos x, and here the signs will cancel, so it's plus 2, and it's equal to 0, right? 0 times sine x is 0. Then it has to be in terms of cos. So on sine squared x, I'll use the identity, which is sine squared x is as good as 1 minus cos squared x. So it's plus 5 cos x plus 2 equal to 0. So that's like 4 minus 4 cos squared x plus 5 cos x plus 2 equal to 0. Okay, so I'll take everything to the right hand side, or technically just divide everything by -1. So starting with the 4 cos squared x, it would just be, the minus 4 cos squared x will become positive 4 cos squared x. This will become minus 5 cos x. And for 4 plus 2, which is 6, it will become minus 6. So remember, we are dividing everything by -1. So this is the equation we'll now be having. And this is what they want us to express. Okay. Our A is 4, our B is -5, and C is -6. So that's how we do it. Okay, shown, because they're saying we should show. So we have done that. All right. So now we want to move on to part B. All right. Let's move on. All right. So on part B, they say, hence, solve the equation. So we want to solve that equation, which happens to be the equation we have already, which we have expressed in this much nicer form. Okay, so I'll copy the equation we got, and I'm going to use that instead of this. So we're saying what we have been given is the same as this being equal to 0. Okay. All right. So I think we are good. All right. So we are just solving this equation here. All right. And we are going to do that. I'll say let a letter like u be equal to cos x. All right. Which means therefore that we have 4u squared minus 5u minus 6 equal to 0. So we can now factorize it here. Okay, so to factorize this, we're going to have 4u and u, which will multiply to give us 4u squared. And let's have 3 and 2. Okay, and 3, 8. I'm sure this should work. And let this be plus, and let this be minus. And I think we have factorized it like we should. Okay, 3u minus this is minus 5u. 3 times minus 2 is minus 6. I think we're good. I think we are good. All right, so it means that the values of u will be -3/4 or 2. So these are the two possible values of u. All right, so taking back the cos x, it therefore means that cos x is equal to -3/4. But 2 will give us no solution. Okay, because cos x, the function cos x only has values that range between -1 and 1. So 2 is out of that range, and so we'll have no solution with 2. So we'll just work with cos x being equal to minus 3/4, all right, which means therefore that x will be arc cos of -3/4. I'll use my calculator for that. So shift cos of -3/4, and it has to be in degrees. All right, let me do a quick one here, and I'm getting 138.6. So This gives us a principal value of 138.6. All right. Now I'll use um the method of finding solutions for cos, which is PV, which is the principal value. So plus or minus the principal value plus 360n. All right. I hope you know this method of finding your solutions, and this is only applicable. This one is only applicable for cos. All right. So it's more like we're doing plus or minus of 138.6 plus 360 n, and n is an integer. All right. So n can be 0, of which when n is 0, we'll be having plus or minus 136. So of those two, the one which is within range will be positive 136. So for our solutions, we'll be having 138.6. Minus 138.6 is out of range. All right, degrees. And the next value, we'll have n to be 1. All right, so minus 138.6 plus 360 of 1. Okay, minus 138.6 plus 360 gives us 221.4, which is within range. So I'll also have that 221.4, 221.4 degrees. All right. We'll also do, here we did negative 138.6 plus 360 of 1. Let's do positive 138.6 plus 360 of 1, which will be out of range. So actually, the two values that I'm getting, which are within range, are these ones here. These are the solutions here to part B. Right, let's move on to the next question. And the next question is number 6. On number 6, the question says, the diagram shows a motif formed by the major arc AB of a circle with radius R and center O, and the minor arc A or B of a circle, also with radius R, but with center C. The point C lies on the circle with center O. So on A, they say, given that angle ACB is equal to K pi radians, state the value of the fraction K. State the value of the fraction K. All right. Okay. So you really need to understand this question, and reading this part really helps you gain a better understanding of what's going on. So I'd advise you go over these statements, this part of the question, this description, so that you really understand how your shape is like and whatever important things you need to take note of. All right. Okay, so we have a major arc which goes all the way around. That's the major arc there. And a minor arc, A or B, which is right here. And or is the center of the bigger circle. All right, if it was complete. And we also have the radius of the bigger circle being OA, and it's equal to R. Okay, we have it all like this, and AC is equal to R. Okay, so we can actually by symmetry see that if we extend from C going towards B, and or draw the line OB, they should also have values R and R by symmetry. And if we draw a line from O to C, then it should also have a value R. Why? Because OC is as good enough a radius of the bigger circle, if it was complete, as OA is the radius of the same circle. So these two should be equal. So we actually have two equilateral triangles here. And if we have equilateral triangles, we know that the angles in an equilateral triangle are 60-degree angle, which is a third pi, right? So when they say on part A, we should, given that the angle ACB is k pi radians, the angle ACB combines this angle here, which is a third pi, and this angle here, which again is a third pi. Okay? Why a third pi? Remember we said these are equilateral triangles. I hope I said equilateral, not isosceles. Equilateral triangles, and they have equal angles, which are a third pi h. All right. So we are saying that the angle ACB is 2 times a third pi. So it's 2 thirds pi, and therefore K, the fraction, is 2 thirds. So that's how we answer part A. Okay, let's move on to the next part of the question, which is B. They say on part B, we should state the perimeter of the shaded motif in terms of pi and r. So keyword here is perimeter, which is like the distance right around the shape. Okay. So here, there are two ways that we can go about this, from what I can see. To find the perimeter of the motif, you can consider here the fact that the arc AOB is equal to the arc ACB. All right. The arc AOB is equal to the arc ACB, which would mean that if we combine the major arc AB and the arc AOB, which is equal to ACB, we should form a complete circle. And that should mean that the perimeter of the motif is equivalent to the circumference of a circle, which is found by the formula 2 pi r. So since on the question, they say we should state, okay, let's go back to the question. On the question, they say we should state the perimeter of the motif. We can simply say that it's 2 pi r, and that's the answer. But if you want to be technical, if you really want to do it, really want to show your work in, another way we can go about it is actually to do the calculations of the lengths of the arcs. So we would be saying in such a case, okay, an alternative method would be saying that the perimeter is the sum total of the major arc plus minor arc. And for major arc, the major arc, let's go back to the diagram. For the major arc, we are considering the radius r, okay, there's 2 radii, and the angle that subtends the major arc AB is this angle here, which we find by saying 2 pi minus 2 thirds pi. Okay, remember this and these two are 2 thirds pi. They're thirds pi each, so that's 2 thirds pi. So 2 minus 2 thirds, we know that that's 4 pi over 3. So the angle that subtends the major arc AB is 4 pi over 3. So the length of arc will be r theta. So for the major arc, it's r theta. So it's r of 4 pi over 3. All right, that's the major arc. Okay, and it's plus the minor arc. The minor arc here is the arc A or B. All right, the arc A or B. Okay, you can ignore the red lines. And the center of the circle to which A or B belongs is C. And the angle, the theta, is 2/3 pi, is that pi plus the third pi. So it's 2/3 pi. So the length of the arc A or B is r theta, which again is r of 2/3 pi. So let's have that down here. Okay. So again, that's r of 2/3 pi. All right, so that's going to be 4 pi over 3r plus 2 pi over 3r. All right, so 4 pi plus 2 pi, that's 6 pi. And 6 pi over 3 is 2 pi. So this gives us 2 pi r. All right. So, for 1 mark, you wouldn't want to go all through all this trouble. So maybe just simply stating it like we did using the first method would have been okay. Anyways, let's move on to part C. On part C, the question says, we should find the area of the motif, giving your answer in terms of pi, r, and root 3. So here we want to look at the area, okay? So for the area of this shape here, okay, I want to remove all this, everything I wrote on it. So let me just do a quick one here. Okay, so I'm replacing the original diagram here. So we have it now and it's all good. Okay, so we want the area, the shaded area here. And to find the shaded area, what we're going to do is we are going to find the area of the whole circle. And from the area of the circle, we are going to consider that we have a segment. Okay, this thing here is a segment. Okay, and the part above it is equal by symmetry, equal to that same segment below. So we have two similar segment shapes that we have right here. So what I'm saying here is to find the area, excuse me, the shaded area. Let me write that down. The shaded area, we can say the area of the circle minus 2 times the area of the segment, which are those segments that we have. All right. The area of a circle is pi r squared. It's minus 2 times. For area of a segment, I would like to believe you know the formula for area of a segment, which happens to be half r squared theta minus sine theta, right? Just memorize this formula for area of a segment. It'll serve you a lot, okay? So this is how you find the area of a segment. So I'll say here it's half times half r squared of theta minus sine theta. What is theta? Theta should be 2/3 pi, right? Okay, for this, remember the angle, if we close this, we say the angle here is 2/3 pi. Okay, so theta is 2/3 pi. Okay, it's a little down. So 2/3 pi minus sine of 2/3 pi. All right, so that's how we're going to be calculating the shaded area. Okay, so that's going to be pi r squared minus the 2's cancel here with r squared. Okay, r squared of 2/3 pi and sine of 2/3 pi. Let me just calculate that on my calculator. Let me go to the right mode. It has to be in radians. So sine of 2/3 pi. Well, that should be √3/2. So we have √3/2 right here. Okay, that's what we have right here. So this is going to be pi r squared minus 2/3 pi r squared plus √3/2 r squared. Okay, now we know here that pi r squared minus 2/3 pi r squared is a third pi r squared. So we have a third pi r squared plus √3/2 of r squared. All right, we should give us a final answer of a third pi plus √3/2 of r squared, just after factoring out the r squared. So that's what they want. They wanted the answer in terms of pi r and √3. So pi r √3, we have them. So that's what I would get for this particular question right here. So that's how we do it. Okay, that's how we do it. All right, so we want to move on, okay, to the next question, which is question 7. So let's do that. All right, so we have question 7 here. Okay, think we're good. All right, let's do question 7. It says, the sum of the first two terms of a geometric progression is 15, and the sum to infinity is 125/7. The common ratio of the progression is negative. Find the third term of the progression. Okay. All right. Let's make use of the information given. They've told us that the sum of the first two terms, so sum to 2, is 15. So we have that information. And they've told us that the sum to infinity is 125/7. So this is the information we have. All right. Now, the first two terms, okay, this information tells us that A plus AR is equal to 15. And this information we got tells us that for sum to infinity, we find it by A over 1 minus R. So that's the one that's equal to 125/7. Okay. Now, this can be simplified to A of 1 plus R is equal to 15. Okay, and we can actually make A the subject, which will be 15 over 1 plus R. And even here, we can make A the subject, which will be 125/7 of 1 minus R. So we can solve these two equations simultaneously just by equating them, right? So we have 15 over 1 plus R being equal to 125 of 1 minus R over 7. So we're going to cross multiply, and if we do, 15 times 7 is 105. And on the other side, cross multiplying these two will give us 125 of 1 minus R of 1 plus R. Okay. All right. So here, that's 105 being equal to 125 of this is the difference of two squares, which is 1 minus R squared. So 105 is equal to 125 minus 125 R squared. So 125 r squared is equal to 125 minus 105 should give us 20. All right. And I hope I've done that correctly. I hope I've done that correctly. So which means that r squared is equal to 20 over 125. Okay, so let me just check on what we have right here. So we have this 105 equals to 125. 1 minus r, 125 minus 125 r squared. Then 125 to the other side, and 125 minus 105 is that. Okay, which happens to be okay. So what I'm gonna do here is I'm gonna square root this, but we need to simplify this before we do anything else. 20 over 125 can be reduced to dividing by 5, 4 over 25, which means if we square root both sides, r will come out as plus or minus 2/5, right? So r is plus or minus 2/5. Okay. Now, since we have r to be plus or minus 2/5, here they say the common ratio is negative. So since they say that, we are going to use r is equal to minus 2/5 because they say the common ratio should be negative. And we therefore can find a, and we can find a from any. So 15 over 1 plus r, that's 15 over 1 plus r, which is 1 minus 2/5. So this is as good as 15 divided by 1 minus 2/5, which is 3/5, which is 15 times 3, 5 over 3, which is, which should give us something like 15 times 5 over 3. So 25. So A is 25. So with A is 25, R is minus 2/5. So what is the question saying, by the way? Find the third term. So the third term is u sub 3 and is equal to AR squared. And this should be A, which is 25, of R squared, which is 4 over 25. And we know that the 25s will cancel, so we'll get the answer as a 4. So 4 is the answer right here. Okay, 4 is the answer right here. Let's move on to number 8. Okay, we're on number 8 already. Okay, so number 8, we have this amazing graph. And the question says the diagram shows the curves with equations y is equal to that and y is equal to that, meeting at points A and B. So on part A, they say, using substitution, which is u is equal to 2x minus 3, find by calculation the coordinates of A and B, right? So we want to answer that question right there. All right. So we're talking about coordinates of A and B where the two graphs meet, right? When the two graphs meet, we can form a simultaneous equation where we can say that 2, or let me use a black pen, 2 of 2x minus 3 to the 4 is equal to 2x minus 3 squared plus 1, all right? Okay, so we have to use the substitution, all right? So using the substitution, that will be 2, let me put it here. Okay, that'll be 2u to the 4 being equal to u squared plus 1, okay? let's take everything to one side. So that's 2u to the 4 minus u squared minus 1 equal to 0. All right. So this is a thing that can be factorized. We can treat it to be like a disguised quadratic. And if we try to do that, to factorize it, we can have 2u squared here and u squared here, 1 and 1, then plus here and minus here. I think this should be fine. So the first one will be either 2u squared plus 1 equal to 0, or u squared minus 1 is the one that's equal to 0, okay? So here we have no real solution, okay? So the only answers, the only values of u we get are plus or minus 1, all right? So plus or minus 1 are the values of u, which therefore means that since u is 2x minus 3, 2x minus 3 is equal to plus or minus 1, which means x is equal to 3 plus or minus 1 all over 2. All right. So that's what we'll be having right there. So the values of x will be 3 minus 1, which is 2, and 2 over 2 is 1. And 3 plus 1, 4, 4 divided by 2 is 2. So the values of x are 1 and 2. So we have values like this. All right, so the values of x and the values of y. So we have 1 and 2 for the values of x. So what are the values of y? We can substitute them back into these equations, all right? So substituting 1, we'll be having 2 of 1 minus 3 to the power 4. So 2 of 1, that's 2, 2 minus 3, that's minus 1 to the 4 is 1, so 2. So we'll be having 2 here. And substituting 2 back, I'm using this first equation. If I place 2 in place of x, it'll be 2 times 2, 4, 4 minus 3, 1. 1 raised to the power 4 is 1 times 2, it will still be 2. So we will get these values. So the coordinates of A and B are A is the 1, 2, and B is the 2, 2. All right. I've just done that in order because A is more to the left, so it's a lower value of x, and B is the greater value of x, all right? So 1 and 2, 1, 2, and 2, 2. So that's how we answer part A. Let's go on to B. Find the exact area of the shaded region, right? Find the exact area of the shaded region. Okay, so we have a bit of work to do here because they want us to find the area, the exact area, and this here is the shape that they want us to work with, All right, so to find the area they want us to find, the shaded area, we know that here we have a line, okay. Let me make it thinner, maybe red. And this is the line 2. Remember, we had the coordinates, the y coordinates being 2's, but that doesn't matter though. We are going to find the area for the shaded area. We'll find the area under the, okay, this is 1, and here, this is 2, okay? So, we'll find the area under this curve, all right? So, which means the whole area. We'll find the whole area under that curve, and we will subtract the area under the other curve, which is the curve that is lower down. So the area under it is the one I'm shading in black. So if we subtract those two areas, we'll get the shaded area indeed. So that's basically what we're going to do. Okay, so let me remove this. So we're saying here, for the exact area of the shaded region, I'll say shaded area is equal to, and I'll start with so we're integrating from 1 up to 2, and we're integrating area under the first curve, which is the curve, this curve here, 2x minus 3 squared plus 1. With respect to x, and this minus the integral from 1 to 2 of the other curve. What does it say? The other curve is 2 of 2x minus 3 to the 4. All right, so 2 of 2x minus 3 raised to the 4 with respect to x. All right, so let's simplify what we have. All right, so integrating this, we should be having 2x minus 3 raised to the 2 plus 1, which is a 3. And that's going to be over, and here we'll be having 2 of n plus 1, which is a 3. And it's going to be plus. Integrating 1, we know that that gives us x. And we have the limits 1 up to 2. And that's going to be minus. On this part, I'll factor out the 2. And I will integrate 2x minus 3 raised to the power of 4. All right, so that's going to give us 2x minus 3 raised to the power of 5. And that's going to be over. And here we'll be saying that's of 2 of 5. All right, so this is basically what we have. The limits are from 1 up to 2. All right. Now from here, I just want to simplify this a little bit more, all right? So basically, what we have right here is 2x minus 3 raised to the power of 3, and it's all over 6 right here. So we have a 6 down at the bottom, and it's plus here. That's plus x, right? And we have the limits from 1 up to 2, and it's minus 2 off. And here we'll be having the 2x minus 3 raised to the power of 5, and that's going to be over, and it's over 10, all right? So this is what we need to simplify. So I'll substitute 2 in the first one right here. And substituting 2, that's 2 times 2, which is 4, and 4 minus 3 is 1. 1 to the 3 is still 1. So it's a sixth. Plus, substituting 2 here, that's going to be plus 2, and it's minus. Substituting 1 now. If you substitute 1 here, is 2 of 1 minus 3, which is minus 1, and minus 1 cubed is minus 1. So we have a minus a sixth here, and it's plus. Substituting 1 here is plus 1, and it's minus. Now we're going on to the other part. So we have a 2 here, and substituting 2 for x inside the bracket, we'll be having 2 times 2 with it, which is 4, and 4 minus 3, that's 1. 1 to the power of 5 is 1, so 1 over 10. And that's going to be minus. Now we're substituting 1. And 2 of 1 is 2. 2 minus 3 is minus 1. Minus 1 to the 5 is 2 minus 1. So we get minus a tenth. So minus of minus a tenth is as good as plus a tenth. So this is what we have. And that's what we need to simplify. So we have a sixth plus 2 plus a sixth. And that's minus 1. All right. And it's minus 2 of a tenth plus a tenth. A tenth plus a tenth is a fifth, and times 2, that's 2/5. So basically we have it like this, all right? So here we have a sixth plus a sixth, which is a third, plus 2 minus 1, which is 1, and it's minus 2/5, all right? So let's just do a quick working of this. So it's a third, and it's a third plus 1, and it's minus 2/5. And we are getting here 14 over 15. So the result we get here is 14 over 15. Okay, so this here happens to be the solution. That's actually the area required. Okay, so that's basically how we do it for this particular question, part B. Now we're moving on to the next question, which is number 9. Now on number 9, the question says express 4x squared minus 12x plus 13 in the form 2x plus a squared plus b, where a and b are constants. All right, so how do we do this? All right, I'm going to factor out 4. Okay, so let me do that now. Okay, so factoring out 4, we'll be having x squared minus 3x. All right, and it's plus the 13 that's already there. So I'm just factoring out the 4 from the first two terms, all right? So that's going to be 4, now completing the square, of x minus 3 over 2, close bracket squared, okay? And this minus of minus 3 over 2 squared, close bracket, and it's plus 13, all right? So what we have now is 4, and it's 4 of x minus 3 over 2 squared minus of 9 over 4, close bracket, and it's plus 13. Now, I'm multiplying the 4 now into the square bracket. So that's 4 of x minus 3 over 2 squared minus, and 4 times minus 9 over 4 is minus 9, and it's plus the 13 right there. So 4 is like 2 squared. So it's as good as we have 2 squared of x minus 3 over 2 squared, and minus 9 plus 13, we know that gives us 4, all right? And now for this, we have 2 squares multiplying each other, which is as good as we have 2 of x minus 3 over 2, all right? And everything is under squared. So that's how we can put this, the product of these two squares, all right? So I'm actually using the fact that if you have a squared, b squared, it's as good as a, b, o squared. So basically that's what I've applied on this particular step. Okay, so this is going to be multiplying 2 into the bracket. That's going to be 2x, all right? And 2 times minus 3 over 2 is minus 3, close bracket, squared, plus 4. So what we now have is in the form they wanted to be in the form 2x plus a squared plus b. That's exactly what we have obtained, and that's how we do it, all right? Let's go on to the next part of the question. Okay, so it says the function f is defined by f of x is equal to 4x squared minus 12x plus 13 for for values of x ranging between p and q, where p and q are constants. The function g is defined by g of x equals to 3x plus 1 for x being less than 8. All right. So in part B, they say, given that it is possible to form the composite function g of f, find the least possible value of p and the greatest possible value of q. All right. So you really need to understand your composite functions. All right. What we have here, we've been told, because we are considering g of f, we have been told that for g of x, the domain is x is less than 8. So when we now talk of g of f, it means that f has gone onto the place of x, because the function is g of x. So when we are talking of g of f, as they say, we are replacing f for x, all right? So what that will mean is that since g of x is has a domain x is less than 8, it also follows that g of f should mean that f is less than 8, okay? So that's what's gonna help us to find the least possible value of p and the greatest possible value of q. In other words, the domain of the function f. So f is less than 8, which means that 4x squared minus 12x plus 13 should be less than 8. I'll take the 8 to the left, so we'll be having 4x squared minus 12x, and then plus 13 minus 8. We know that that should be 5, right? And it's less than 0. And now we can factorize what we got right here. So let's do the factorization. So I'll be having here, if we factorize this, 4x squared, we can split it into 2x and 2x. And products of 5, we can have, since it's a minus and a plus, we can have minus 5 and minus 1, and minus 10, minus this, minus 12. I think we're good. So we have factorized it, okay? Which means that the critical values that we are going to get are going to be found when 2x minus 5 of 2x minus 1 are equal to 0. So here we'll get x coming out as 5 over 2 and x coming out as a half. All right. These are the two possible values of x. All right. So we can now find the solution by making use of the quadratic curve. All right. So I have here x-axis, and we will have the graph like this. The smaller value is a half. The bigger value is 5 over 2. And we're talking about less, okay, less than 0, which means negative. And we know that the graph is negative for values of x between a half and 5 over 2. So basically, the solution set is half less than x less than 5 over 2. So according to what the question is saying, they wanted us to find the least possible value of p, so, and the greatest possible value of q, and it's p less than x less than q. So we found it in this form. So we are saying least possible value of p is a half, and greatest possible value of q is 5 over 2. So that's basically how we do it for this question right here. And that's it. Let's go on to part C. On part C, the question says, find an expression for g of f of x. All right, so g of f of x, we know that f of x is right here, 4x squared minus 12x plus 13, right? So let's write that down. So we have 4x squared minus 12x plus 13. And we know that the function g is such that g of x is 3x plus 1. So basically, we'll be saying that's 3 of 4x squared minus 12x plus 13 plus 1, all right? Which is like 12x squared minus 36x plus 39 plus 1, which then gives us a result of 12x squared minus 36x, and is plus 40. So that is the expression for g of f of x, all right, as required. So that's how we do it for part C. Let's go on to part D, where they say the function h is defined by h of x is equal to 4x squared minus 12x plus 13 for x is less than 0, okay? So x is less than 0, that's what we got right here. x is less than 0. Right, so they want us to find an expression for h inverse of x on D. Right, so to find the inverse, we will have y being equal to 4x squared minus 12x plus 13. This is the same as saying y is equal to, and I think we had completed the square here, hadn't we? Let's check on that. Uh, Completing the square, we got 2x minus 3 squared plus 4. So we are going to make use of that. So this is the same as 2x minus 3 squared, and it's plus 4. So that's what we're going to be making use of right here. And we'll interchange the variables, which therefore means that x is equal to 2y minus 3 squared plus 4, and we'll make y the subject. So x minus 4 is equal to 2y minus 3 squared, and we square root both sides. So we'll be having plus or minus the square root of x minus 4 is equal to 2y minus 3, and we make y the subject. So eventually we'll be having y coming out as 3. Okay, let me write the 3 properly. 3 plus or minus the square root of x minus 4, and it's all divided by 2. I've just made y the subject. All right, it's all divided by 2. All right, but we have plus and plus or minus here, so we need to determine which one is the right one. Okay, so our key is just looking at the domain. All right, the domain of the function is equivalent to the range of the inverse. And the range of the inverse is what we have obtained here, and it's one of the two, either with a plus or with a minus. So x is less than 0, which means we want our choice here is one which will give us a value that is less than 0. Is it 3 plus the root of something, or is it 3 minus the root of something over 2? So basically, it's quite clear, therefore, that h inverse of x should be 3 minus the square root of x minus 4, and it's all over 2. All right, that's how we can get a function that is less than 0. Okay. All right, so you really need to understand that, and it's quite important that you do. All right, so that's how we do it for part D. Let's move on. Let's move on to the next question. So we're moving on. Let me take you to the next question. Okay. Okay, here we are on question number 10. We're on question 10, and let's do question 10 as quickly as possible. All right. So on question 10, it says a curve has a stationary point at 2 and minus 10 and is such that d squared y by dx squared is equal to 6x. And they say on part A, find dy by dx. All right. So let's answer this. In order for us to find dy by dx, we have to integrate the second derivative, which is d squared y by dx squared, with respect to x. All right. So in other words, we're integrating 6x with respect to x, and we know that this gives us 6x squared plus 1. So that's 6 over 3. All right, so that will be 6x squared over 2, okay, plus c, which is the same as 3x squared plus c. So this here is dy by dx, all right? But we know that at the stationary point, okay, at stationary point, okay, we know that dy by dx should be equal to 0. And here we're also been told that at the stationary point, the x value will be 2 and x will be 2. So we can use that substitution to get the value of c. So 2 to get the value of c. So dy by dx is 0, so 0 is equal to 3x squared plus c, which is 3 of 2 squared, which is 12, plus c. So therefore, we get that c is minus 12. So dy by dx as required is 3x squared plus c, which is minus 12. So that is the answer for part A. Let's go on to the next question, part B. Okay, let me just underline the answer we had for on part A. Right now, on part B, they say, find the equation of the curve. All right. So to find the equation of the curve, it's y is equal to, we have to integrate. Already, we have the dy by dx, so we are integrating the dy by dx. We are integrating the 3x squared minus 12 we got with respect to x, and let's do that. So that's y is equal to, integrating 3x squared will give us x cubed minus 12x plus c, all right? And we know that a point on the curve is the point 2 and minus 10. So since we have a point 2 and minus 10, it means when y is minus 10, x is 2. So that's 2 cubed minus 12 of 2 plus c, all right? So that's minus 10 is equal to 8 minus 24, which is minus 16, right? Okay, plus c, and we will get c minus 10 plus 16, so c will be a 6. So therefore, the equation of the curve should be y is equal to x cubed minus 12x plus c, which is a 6. So this is what we get for the equation of the curve. So that's how we do it for part B. All right, let's go on to part C. They say find the coordinates of the other stationary point and determine its nature. All right, find the coordinates of the other stationary points and determine the nature. Right, so dy by dx, here we are using this, what we got right above. So we are differentiating x cubed minus 12x plus 6, which is 3x squared minus 12. Remember, if we differentiate a constant, we get 0. So it's just 3x squared minus 12 that we are going to be working with. And we know that at the stationary point, it is going to be 0. So we are saying that if we factor out 3, we'll be having x squared minus 4 equal to 0. Okay, so basically x squared minus 4 is equal to 0. 3 of x plus 2 of x minus 2 equal to 0. So the possible values of x should be plus or minus 2 if we equate each one of the factors to 0, all right? So these are the possible values of x right here. Now, we already had the fact that one of the values of x is a positive 2, because we already have had the point 2 and minus 10. So the other stationary point should occur when x is equal to minus 2. And when x is minus 2, what is the value of y? We go back to the original equation, which is x cubed minus 12x plus 6. So it's minus 2 cubed minus 12 plus 6, all right? I've just substituted that. So that's minus 8 plus 24 plus 6, and that should give us 22, right? So the other stationary point, the other stationary point is the point minus 2 and 22, all right? So that's how we do it here. And they say determine its nature. All right, so we need to find d squared y by dx squared. We differentiate the dy by dx. and this should give us 6x, right? We get 6x right here for the other stationary point, all right? And when x is equal to -2, we can see that d squared y by dx squared should be 6 of -2, which is -12. So therefore, the point is, since it's less than 0, okay, it's negative, less than 0. Therefore, the point is a maximum. All right. So this is how we do it right here. All right. Okay, let's move on to the next question, part D. It says, find the equation of the tangent to the curve at the point where the curve crosses the y-axis. All right. The equation of the tangent. Okay, so to find the equation of a line, we know that we need to find the gradient. So let's find dy by dx. We know that dy by dx is equal to, what is dy by dx, by the way? 3x squared minus 12. 3x squared minus 12. And where the curve crosses the y-axis, we know that x will be equal to 0, which therefore means that dy by dx should be equal to 3 of 0 squared minus 12. So the gradient will be -12. All right. And they say where the curve crosses the y-axis. So when x is equal to 0 as well, y is equal to, the equation of the curve is y is equal to x cubed minus 12x plus 6, x cubed minus 12x plus 6. So 0 cubed minus 12 of 0 plus 6. So y is 6, right? So therefore the point of the y-intercept is a 0 and a 6, because we got y to be 6 and x to be 0 here. All right. So very important. So we can now just write down the equation of the tangent. So therefore, equation of tangent will be y is equal to mx, which is minus 12x plus c, which is the y-intercept, which is a 6. So this here is the answer to part D. All right, let me just underline it well. So that's how we do it right here on part D. All right, we need to move on to the very last question, which is number 11. All right. So on number 11, we have this awesome diagram drawing of a circle on a graph and stuff. Let's read what they are saying here. Okay. They are saying here the diagram shows the circle with the equation x minus 4 squared plus y plus 1 squared equal to 40. Parallel tangents, each with gradient 1, touch the circle at points A and B. So on part A, find the equation of the line AB, giving the answer in the form y is equal to mx plus c. All right. So this is what they want. So they want us to find the equation of the line AB right here. All right. The equation of the line AB is what they want us to find. Okay. So you know how if you want to find the equation of a line, you just need two things. You need the gradient of that line, and you also need a point on the line. So if I draw a line that goes through A and B, which is the line that whose equation they want us to find, okay, the line will have a center somewhere, and we know that the center, the middle of the line should be the center of the circle. All right, because A and B should be the radius, the diameter of the circle, since it's making tangents with at both ends of the circle. all right? It is only a tangent that can do that, okay? It is only a tangent that can do that, all right? So from the equation of the graph, the equation of the circle, we can deduce the midpoint, the center of the circle to be from -4, that's a 4, and from 1, that's a -1. So this is a point which is the midpoint of AB and which also happens to be the center of the circle. All right. So we know that a point on the line AB is 4 and -1. All right. We also know that the gradient, okay, because we've been told that the parallel tangents have gradient of 1. So this tangent has a gradient of 1, which means, and is perpendicular to the line AB. So the product of the gradients should be -1, which means that the gradient of the line AB should be -1, so that the product with the tangents should be -1, basically. So we can now find the equation of the line AB simply by saying y minus -1 is equal to m, which is -1 of x minus 4. So I'm using that formula. Y minus y1 is equal to m of x minus x1 to find the equation of the line. And I'm sure you know that already. So y plus 1 is equal to minus x plus 4. So the equation should be y is equal to minus x, and subtract 1 from both sides is 4 minus 1. So it's plus 3. So that's our answer here to part A. All right. That's the answer to part A right here. Let's move on to part B. All right. So on part B, down here, they say find the coordinates of A, giving each coordinate in third form. All right. So what is A? Let's go back. A is a point on the circle where the circle and the tangent meet. Okay. So that's the point A here. And it's also a point where the line AB meets with the circle. So since we have the equation of the circle and we've found the equation of the line AB, we can use the two and solve them simultaneously. So I'm going to take the equation of the circle and I'm going to paste it down here. So that's the equation of the circle here. And we're also going to take the equation of the line AB. All right. And we're going to use this to solve them simultaneously to find the coordinates, right? So here it is. Okay. So we have this two. So if I use substitution, I'll say right here, x minus 4 squared plus, and in place of y, I'll substitute minus x plus 3. So it's like we have minus x plus 3 plus 1, which already is inside the bracket, squared is equal to 40 right here. So this is like x minus 4 squared plus minus x plus 4 squared equal to 40. So expanding, we get x squared minus 8x plus 16, and is plus, expanding here, x squared minus 8x plus 16, and that's equal to 40 here. All right, x squared plus x squared is 2x squared minus x is minus 16x. So we have minus 16x here. 16 plus 16 is 32. All right, so it's plus 32, and the 40 comes to the left, it becomes minus 40, and it's equal to 0. So 2x squared minus 16x, and 32 minus 40 is minus 8. It is equal to 0. Divide everything by 2, so it's as good as we have x squared minus 8x minus 4 equal to 0, right? Now, we can solve this for x, all right? So let's use the quadratic formula. So x is equal to, and that's since we cannot factorize this, all right? So it's x equal to minus 8 plus or minus the square root of minus 8 squared minus 4ac minus 4, and that's over 2 of a is 1. All right, I'm going to quickly use my calculator for this to get our result. So, okay, let me just do that quickly. 1 minus 8 and minus 4. Okay, so I'm getting the values of x to be 4 plus 2 root 5. And the other one is 4 minus 2 root 5. 4 minus 2 root 5. So these are the two values of x we're getting. So these are the points of intersection between the line AB and the circle, all right? These are the values of x for the points of intersection. So the line AB and the circle have those two values for the x values, 4 plus or minus 2 root 5. So the 4 minus 2 root 5 should be for A, and the 4 plus 2 root 5, the plus should be for B, seeing their relative positions on the Cartesian plane. So the question here wants us to find the coordinates of A. So for the x coordinate of A, we'll use the 4 minus 2 root 5. Okay, so for A, x is 4 minus 2 root 5. So the question is, what is y? All right. So for y, we are going to use y is minus x plus 3, which will be minus of 4 minus 2 root 5 minus x plus 3, they say, right? Minus x plus 3, all right, like that. So y should be equal to minus 4 plus 3, which is minus 1, and minus of minus that is plus 2 root 5. Okay, so the coordinates of A should be 4 minus 2 root 5, and it's minus 1 plus 2 root 5. All right, so these are the coordinates of the point A as required in this particular question here. And that's how we do it, all right? That's how we do it for part B. Let's go on to part C, which happens to be the very last part on our question. So it says, find the equation of the tangent at A, giving the answer in the form y is equal to mx plus c, all right, where c is in surd form, okay, where c is in surd form. So how do we go about this? Equation of the tangent at A. To find the equation of a line, we need the gradient. So we know that the gradient of those tangents, we've been told that they are each 1, all right? And a point on the, we are going to use the 4 minus 2 root 5 minus 1 plus 2 root 5. So the equation of the tangent should be y minus y1, which is minus 1 plus 2 root 5 is equal to m, which is a 1, of x minus 4 minus 2 root 5. So that'll be minus 4 plus 2 root 5. All right. So that's going to be y plus 1 minus 2 root 5 is equal to x. All right. Minus 4 plus 2 root 5. Okay, so if we take everything to the right side except for y, we'll be having y is equal to x, and 1 goes to the right, and minus 4 minus 1 is minus 5, and minus 2 root 5 goes to the right, and it will give us plus 4 root 5, and this becomes the answer. That's the equation as they require, and that's how we do it right here. And that ends the paper. Thank you so much for watching. WalterMaths.com is the place to be. See you there, and see you next time.